Okay. First thing we'll do is go over the practice assignment that I sent you. And Maureen had them all correct. Maureen, that is so great that you understood what we went over and we practiced enough that you understood it. Now, Mercedes, I
Yes,
want
it's
you to
brother.
do number 1. Read it and tell me the answer. We're still on exponents, multiplication. We'll go through this, probably do a couple of more, and then we'll go to division because your next assignment will be on division of exponents. And remember, I told you last time your assignment will be on multiplication only, right? Okay, so I'll say these. Read number 1 and tell me the answer.
Okay, number one say 70. Can I 70 to the 100 power
Yes.
plus 70 to the 40 power is equal to what? And I choose
Where do
the,
you get a plus?
oh, sorry, times, sorry, pardon.
Times,
No.
asterisk or dot
So what
or
happened is this,
X
no, I'm not seeing
is
the time.
time.
I
Okay,
know it's,
that means
I,
multiplication.
yes, I know it's multiplication. I just
So,
didn't see the sign of the better.
okay, so what is your answer?
My answer would be B,
Why B?
because when you do multiplication, you subtract the exponent.
Maureen,
And
is that right?
No, you add.
You add multiplication, add
Multiplication add.
made a mistake.
division, subtract. Mercedes, you remember that? We went over it, did a lot of examples.
Yes,
Mercedes, you remember?
I don't know, I made that mistake.
Multiplication, you do what, Mercedes?
You add, you
You
say?
add. Division, you subtract. So what is the answer, Mercedes?
Answer would be D.
That's right. Answer would be D. Okay. Answer D. So let's just put it here.
I don't know what made me put.
Mercedes, I want to make sure now I don't want you to get
I
confused on
understood,
this
but I'm just
again.
wondering why did I put what caused me to?
What caused you to subtract?
I'm just thinking, why did I do subtraction?
Now, why did you subtract? When
Because
the rule for multiplication of exponent is to add the powers. If it were division, you would subtract. If this was 70 to the 100 divided by 70 to the 60th power, then you would subtract. I'm 70 to the 40th power. Okay? Mercedes, is that clear?
yes, yes, yes.
So do you know why you reversed it? Went to the division rule?
I'm just thinking, why did I do that? I did understand it so good, but I don't know why.
I know you did. We
Why?
went through examples. You answered them perfectly. That's why I'm surprised when you got the answer you did that applies to a division. Okay? So you okay now?
Oh yeah, I see. Yeah, I understand why I made an arrow.
Why?
I just misunderstood I don't know if it because the sign was so small. 'Cause like a while ago, I looked at the sign, I thought it was plus, but I see I don't know how comes I made that mistake because I
Oh,
knew
you didn't realize that was an asterisk?
that's what you remember a while ago I just made the same mistake, miss. I
Well,
just
you
made
said plus.
yeah when we went to multiplication sign.
Yeah, because multiplication, now remember, what are the different signs for multiplication, Mercedes?
You have the dot,
Right?
and you can write the by. If you say by,
You could write what?
by.
What's BY?
When when you say multiply, you could put by between the two numbers too. But
BY? Where did that come from?
No, because you got go on here, Mark. Multiply 10 to the fourth by 10 to the second. That's what she meant.
yeah,
What did she mean by BY?
You got number 3, right? As multiply 10 to the power 4 by 10 to the power 2.
Yeah, but that's not a symbol for multiplication.
I know.
By is not a symbol for multiplication. That's just the wording I used, but that's not a symbol. By
is it
is not a symbol, Mercedes. The symbols are asterisk, dots, the X,
X.
side by side, or you could put them in parentheses. But not the by. By is just the wording.
okay?
You got it?
Yeah, yes, thank
So
you.
asterisk is on the same level of a dot or X or parenthesis, or if they were side by side. Like if you had 2X, that means 2 times X. Okay. 2P, 2 times P.
Okay.
Okay. All right. So let's go. Any questions now? Number one, Mercedes.
No, miss, I just feel so bad that I made a mistake. I was looking
Mm.
forward to get all of them right. I really
You
Yeah,
feel
I
bad
just
about what, Mercedes?
yeah, I
What
just
you
thought
feel bad
I
I
about?
was,
thought you
like,
and Maureen would have gotten them all right.
I because I knew, I think I don't know, I made a mistake.
But yet, Mercedes, you had this one correct. What's the answer for number two?
Number two, the answer was Q to the
Q to the what? Q to the sixth times Q to the third is equal to what?
oh
Q
yes,
to the
Q to
what
the
power?
ninth power.
What is the number?
Q to the ninth power.
Yes. Now, that's why it's strange that you missed number one,
That's
right?
why I'm mad with myself.
Right, because it's the same thing. Isn't it the same thing? It's multiplication,
I don't know. Oh, I made a mistake too.
add the powers, asterisk for the multiplication symbol, and you got number two right, but yet number one
Got
not.
number one wrong. That's why I'm saying, how on earth is that? I'm looking at it.
Really,
I
really strange. That's why I was
I was
surprised.
expecting to get number one right. So when you show me, give me the reply that I didn't get it right. I said, oh, I can't believe I feel really bad. Honestly.
Yes, I was really, but that's all right. You won't miss that again. Now, number three, Maureen, what's the answer? Multiply 10 to the fourth by 10 to the second.
Can you scroll down a little bit, Miss
10 to the 6.
Oh, you want me to scroll where?
Oh, two. Can I see number three?
Can you see
Down.
it now?
No, down. No, the other way. The other way. Scroll the other. I see four.
Well, this is, let's see,
Keep-
let me,
3 at top number 4. So how come you can't see
can you
3?
see it now?
How you see 4?
Hold on. I see why I got something across my screen. I should move. You see, I got
Uh,
it.
Can you see it?
Yeah. Okay, I'm good now. I moved that thing from in front of the screen.
Oh, okay, so,
Yes, I can see it.
okay, so I can go back. All right. Maureen, what's the answer number three?
C. 10 to the 6.
Yeah, multiply 10 to the fourth by 10 to the second. There again, just add the exponents 4 plus 2 and you get 10 to the sixth. So answer C. And you had that one correct. Mercedes, you had that one correct, right?
Should I didn't look at my answers.
Yeah, you had that one correct. I sent you back and told you the two that you missed. Okay. Now, Mercedes, number 4, true or false?
I say false.
Why is it false?
First you have two different base, 6 to the third power and times 2 to the third power. So you evaluate them and then you're going to do the exponent, you're going to multiply. So this does not show it that way. It show us that you just say multiply 2 times 6 is 12 to the third power.
But what's
Then
the rule when the
um,
exponents are the same and the bases are different? What do you do? What's the rule?
you evaluate them and then you do multiplication, evaluate the two section and then do multiplication with exponent.
Maureen, what's the rule? Multiplying
You do
this
when they're different. They got the same. They call that at top. You know,
same power.
they still got the same power, but they
And
got the different base.
so what do you do?
So you multiply the base
Right?
and just take the power and make it one number 3.
That's it. You must,
Yeah.
but what you're saying, Mercedes, is when you have different base and different power. All right. Here the
Well,
powers are the
It's the
same.
same. Yeah.
So like Maureen said, you multiply the 6 times the 2 and you get a 12, and it would just be 12 to the third. So that makes this true. So answer A.
so I misunderstood that.
Yes, because the rule that you're giving me about evaluate is when both the power and the base are different. Like if this was to the third and this was to the second, then you're right. You'd evaluate and then multiply. But when your powers are the same, you just multiply the bases. And like Maureen said, then raise it to that power. So that makes this true. 6 times 2 is 12, and the power is the same, and that's the third power.
Oh,
Now, you could have determined this another way. What's another way you could have determined it, Maureen? You could have raised 6 to the third power, take that number, take 2 to the third power, take that number, multiply them out, and if it give you 12 times 12 times 12, then you know it's true.
no.
Mercedes, could you do that, Mercedes, what I just told you?
I'm trying to comprehend this one, miss, because I don't know. Well, I misunderstand this one.
Okay, Mercedes, let's just take this. I'm just telling you another way you could have done it, and you would have.
No, no, not another way, miss. I just want to know why did I made a mistake again.
Oh, because
I was, I
you
was.
took the rule that's for different bases and different powers
So
and
you're
applied it
saying,
to this, but
so
that's
miss.
not the same here.
Okay, so miss, the exponent should be two different number for me to do it the way I'm saying. I
The
was
way you're
saying.
saying it, you're right. The exponents cannot be the same.
Hold on. So what I'm getting. I want to get this part. For this number 4, for me to do it the way I describe it, the exponent have to be two different numbers, right?
That's correct. That is so
Um,
correct.
oh,
Okay.
so once they are the same number, you just multiply the bigger ones and carry the 3 across.
No, say it mathematically correct. Now, once the
Okay.
powers are the same, you can just
Okay.
multiply the bases and
Okay.
apply the power because the power is the same.
Okay. Got you.
All right. But what I'm saying is, okay, the note is correct. What's 6 to the third, Mercedes? What's that equal to?
6
Do
to
it on
the
your calculator. What's that equal to?
just a minute. 6 to the third. I will get 1 second. Find a minute. Okay. 6 to the third power. That's 216.
216. All right. Now let's take 2 to the third. What's 2 to the third?
2 to the third would be 2 times 2 times. That would be 8.
Okay, 2 times 4 is 8. Okay, so that would be 8. Now take 8 and multiply it by 216.
Take 8 and multiply by 260.
That's
Oh,
216, right? What is that equal to?
that equal to 1,728.
Okay, 1,728. 728. There we go. Now take 12 to the third. That in your calculator.
Okay.
112. Raise it to the third power. And what do you get?
I got 1,728.
So aren't they equal?
Yeah.
Yeah. So they're equal. That makes it true. So I'm saying if you got the rule confused, then all is not lost because you could actually do the math and get the answer, right? Because this is equal to the same as when we took the 6 to the third times the 2 to the third. Get the same number, 1,728. Got it?
Yeah. Yeah.
So I'm just saying there's another way you could have done it. You could have found the value of 6 to the third, find the value of 2 to the third, multiply them. Then find the value of 12 to the third. If they're equal, then this statement is true.
All I think about is the way you said you would do it if the two numbers were different. But
Yeah, but the thing
in
is, you
my head, I
applied
forgot.
the
I
rule
forgot.
to a condition
Yeah.
that's not this condition. The powers
Yeah.
are the same.
In my head, I completely forgot that little part of the rule that there should be two different numbers for
Yes,
exponent.
two different powers, right? That's right. And these powers are the same. So just like Maureen said, multiply the basis and apply that power. That's the same. But the other way is to actually calculate it and see if the left side is equal to the right side. And they absolutely are equal, right?
Okay.
Okay. Questions number 4. So that you missed that one, and number 1, strange how you missed that one and got number 2 right, and they're almost the same kind of problem, right? Yeah, but those kind of things happen, Mercedes. You won't make that mistake again. And of course, number 5, Maureen, what's number 5 answer?
C.
Add the 2 exponents, 5 plus 2, and you get 7. So answer C. And Mercedes, you were okay with that one. And that's less like the other one, Mercedes, right?
Yeah.
And you had that one right.
I was looking forward to get all of them right. I just feel
Yeah,
sorry.
I just knew you would have them all right because they are so similar, and the ones that you got correct is just like the ones that you did not get correct, which is really strange.
I don't know what I was seeing where I get it wrong.
Any questions, Mercedes? Because Maureen,
No.
she showed she really understood this. She got them all correct. And Mercedes, you'll do that on the next round, right? Now remember the next one, the next practice, and that's optional. Remember I said when I give you practice assignments on Monday, it's optional for you to do it and send me the answers. It's for practice, but hopefully you will do it and I'll check it. But the next one will be on division only. Okay. So let's go to our other screen here. Let's see. All right.
Give me a minute, Miss Barbara. And I wouldn't take a minute. Just pick up something and come right back.
Okay. All right. Well, let's go. We've gone through. Okay. multiplying with coefficients, just to review here. Maureen, what do you see on the screen?
If the exponent have a coefficient attached to their base, multiply the coefficients together. Coefficients can be multiplied together even if the exponents have different base.
Okay, so even if they have different bases, you can multiply the coefficients. Now here we've got 9x to the third times 3x to the second. 9 times 3 is 27. Multiplication, add the exponents. 3 plus 2 is 5.
Right.
This is 27x in the fifth. Okay. Now, Maureen, this is one for you to do. What is the answer here?
Okay.
Tell me the answer and I will write it.
Back, Mr. Robert.
Multiply exponents with coefficient.
Yeah, we multiplying exponents with coefficients just to practice here. Now, Maureen is telling me the answer for this one. What is it, Maureen?
Yeah, I got to figure out that now.
Multiply the coefficients,
Multiply the
add the powers,
coefficients.
and then add the powers. So what's your
Okay.
answer?
The multiply coefficient, so that is 5 sevens is 35.
Okay, 35. Let me
To
do
the 10.
That's right, 35 to the 10. Mercedes, you agree?
What you're saying to do here? Is a multiply exponent with coefficients.
Yes.
Practice.
And what's the coefficient, Mercedes?
The coefficient is the letter in front of the number.
No,
Don't even mix it up again.
the number in front of the variable. 5 is a coefficient,
And is the
7
variable.
is a coefficient.
Okay. So you multiply 5 times 7 is 35,
Right?
and 6 and 4 make 10.
6 times 4?
No, 6 plus 4, 10.
That's right. Multiply, you add the exponent. So this will be a to the 4 plus a to the 6. So this is a to the 4 plus 6. And that's equal to what? It should be a to the 10th over here. Okay, equals to a to the 10th. So this should be a to the 10th. Right? Let's see, take out that 10. I don't want it to be confusing. Let me just delete. Okay, so this will be 35a to the 10th. Please put that there. 35a to the 10th. So multiply the coefficients and then just add the powers because it's the same base. Any questions? Okay, Mercedes, you can do the next one then. Okay, let's do the next one. Okay. All right. All right, Mercedes, do this one for me.
14.
Okay, so 14. Let's answer there. Okay.
To the F.
1, 4, and what's the power?
The power is F to the minus 3.
F to the minus 3. Very good. Minus 5 and a plus 2. Subtract, you get a 3. You have more negatives than positives, so your answer, your power will be -3. Any questions?
No, miss.
Now notice I use parentheses there for multiplication, right?
Yeah.
You use parentheses, use dot, use X, use asterisk. Okay. Now, let's go to our next. Now, let's go to division. Same base. What do we do with the exponents, Maureen?
Subtract.
Subtract, right? Same base, you subtract. And you got the variables here, the variable a to the n over a to the m, a to the n numerator power minus denominator power. 2 to the 6 over 2 to the third, 2 to the 6 minus 3, 2 to the third, and that means 2 times itself, 3 times 8. Now, make sure you know how to expand these powers, because sometimes your answer might be given in the format of just a number. Say like here, 8. Questions? All right, because the answer could be given as 2 to the third, could also be given as 8, right?
I don't think I'm so clear. You said dividing exponents with the same base.
Same base, the base here is 2, right?
Yeah.
Subtract the powers. So it just be 2 to the 6, the exponent in the numerator, minus the exponent in the denominator. 3 from 6 is 3, 2 to the third, and 2 to the third means 2 by itself 3 times. 2 times 2 times 2 equal 8. I'll say these that clear?
Okay, we see 2 to the 6.
Wait, are you saying that
2
we
to the third
multiply the base?
equals to
We talking division now, Mercedes.
Yeah, I know, but I'm saying the how to do it is when you're doing division, you multiply the base. Am I mixing it up?
No. Division with the same base, we subtract the exponents. So 2 to the 6 over 2 to the third is 2, the base, and subtract the exponent, 3 from 6.
So the answer is 2 to the third power.
2 to the third, right?
Yeah, because I see you have out here 2 equal 8. That's what I'm asking you a question.
No, 2 to the third, it means what? 2 times 2 times 2.
Yes.
And that's equal to 8.
Yeah, I understood that, but I'm just thinking the way you say to do this one. Oh, I see the sample at the top.
Okay, now what's the question, Mercedes?
No, I thought when I see you do the one with 2 times 2 equal 8 is a part of doing it.
Yeah, I'm just saying be able to recognize whether the answer is left as a base to a power or whether it's just a number. And a number means you expanded the power to the third, and that's what the exponent is, the multiplication, right?
Yeah, I
A
understood that.
multiplication of the base by the number of times that the power is. Is that a question? Is there a problem, Mercedes?
No, I was just trying to understand the answer you gave. I thought the 8 was included. Is this another way?
No, I put the 8 here so that when you're given say a division of exponent problems, be able to recognize the answer, whether it's in a base to a power format or whether it's in just a number,
Okay.
right? Because I could give you a multiple choice and I could give you just a number. That means whatever you got for the base and the power has to expand to one of those numbers. Got it?
Either 2 to the third power or 8. Is that it, man?
Yeah, right.
Okay.
Answer could be in either format.
Okay, got you.
And I did it this way so you'll know that you could have the answer in either format.
Oh,
Okay? Questions? So that's with the same base. Subtract the exponents. Right. All right. Now practice. Maureen, you want to tell me the answer to 20 to the 100 divided by 20 to the 40th?
So that'd be 20 to 60.
20 to the 60, 100 minus 40. Okay. See if I can. See. Copy this. I, I'm writing here with a tablet. Sometimes it doesn't work. Let's see. Okay, 20. There we go. 20 to the 60th. Okay, equal. So 100 minus 40 is equal to 60. All right. Now, Sadie's, what about the second one? What is the answer for this one? Equal what? X to the what? Mercedes, you're on mute.
Sorry. X to the 2 power.
Yeah, that's right. X to the second. 5 minus 3. There we go. All right. Any questions? That same base. Subtract the exponents. All right. 100 minus 40, 65 minus 3 is 2. Okay. Now let's go here. There's some more with, and I put them there, 4, x to the 4th divided by x to the 2nd, x to the 4th minus 2, x to the 2nd. 6 to the 3rd divided by 6 to the 2nd, 6 to the 3 minus 2, 6 to the 1, and that's the same as the number 6. Remember that any number to the 1 power is the same. The number is the same. Or even if it were a variable, x to the 1 is just x. P to the 1 is just p. Got it?
Okay.
Mhm.
So that's some more examples. Okay. So let's look at, all right. Here again. Now, here we have coefficients, same base. Remember multiplication, we multiplied and then added the powers. So with division, you divide and then subtract the powers. So 28y to the 3rd over 7y, divide 28 by 7. There you are, right there. That gives you 4. Y to the 3rd, and this is a 1,
Uh-huh.
the default. So 3 minus 1 is y
2.
to the 2nd. Any questions on that problem?
No.
Not quite sure.
What?
Is
Okay,
it the
Mercedes,
same?
I don't want to leave it if you have any doubt.
Is it the same as the last one you just gave us?
This one, we have a coefficient. And remember when we did multiplication, we multiplied the coefficients. So for division, same base, you just divide the coefficients. In other words, 28 divided by 7. So I put it right here. 28 divided by 7. Those are the coefficients. And then just apply the division rule, which is subtraction, right? 3 minus 1, and that gives you the 2. 28 over 7 gives you 4. Questions, Mercedes?
No, miss, thank you.
Okay. Maureen, you okay?
Yeah.
All right. Well, then that means you're okay. Practice. I want you to do those and tell me the answers. Maureen, you want to tell me the answer to the first one?
The answer to the first one is 8p3.
That's right. 16 over 2 is 8. P to the 5. And this is be 5 minus 2. And what's that equal to, Maureen?
2 is 3 minus 3.
Minus?
No, it's 2 from 5 is 3.
Yeah,
It's
just
8p to the power 3.
that's it. 8p
Yeah.
to the power of 3. There we go. Mercedes, you okay with that one? Mercedes, you're on mute.
Oh, I'm sorry. Yes, miss. You divide 2 into 16, give you 8, and then she subtract 2 from 5, leave 3.
That's right. So divide the coefficients, subtract the powers. Now, Mercedes, do the next one. 100x to the 8 over 100x to the minus 3. What is that equal to?
They would say 10x to the
Okay, 10. 100 over 10 is 10. And what's the power on the x?
power will be I know it's 5, but I'm trying to say is plus 5
How are you getting a plus 5?
because I see a minus 3.
So how do you get a plus 5?
I'm subtracting minus 3 from 8.
Okay, so what do you get?
I get 5, but I don't know. I don't quite sure if it's which of the sign to use.
Maureen, what is your answer?
Let's see. Minus 5.
How you get? This will be 8, right?
Yeah.
Minus a minus 3. What is that equal to?
11.
Oh, Lord.
11. Yes.
Always catch me.
Remember those slides, Mercedes?
Oh, Lord. If I just write it down, I'm going to
11 minus minus gives plus. So
yeah.
8 plus 3 gives you 11. Got it?
Mhm.
That's why I started to be doubtful right there because I said, what I don't remember right there. So I just start to write it out now. I say, oh Lord, it's 11.
Well, always write it out, just like I did here, right?
Yeah,
Write it out.
I didn't
Because you
write well.
remember, you got a minus for the subtraction. That's the rule for dividing. You subtract the powers, right? So you have this
Mhm.
minus for the subtraction, and you have this minus for the sign on the power. So minus minus is plus. 8 plus 3 is 11. Got it?
Yes, miss.
Okay. Watch your signs, because you'll have some that won't always be positive. Okay. All right. Now, let's see. Now, exponents, different bases. Okay, Mercedes, read this.
Dividing exponents with different bases. When the
Mhm.
bases are different and the exponents of A and B are the same, we can divide A and B first.
Now, I put A and B, and I put an example here. Here's A to the n divided by B to the n. So you divide the bases, A and B, and then raise it to the n power. So you got different bases, but the same power, okay? Now, if you apply it to a number, 6 to the third over 2 to the third, you divide 6 by 2, that gives you 3, then raise it to the power of 3, and that means 3 by itself 3 times, it gives you 27. Any questions when the
So the
bases are different?
so the answer would be Either 3 to the third power or 27.
That's correct, Mercedes. Very good. Maureen, you okay with this one?
I think so, yeah.
Okay. All right. So let's go to, okay. Different bases practice. Mercedes, what's the answer for the first one?
Okay, different. We subtract. The answer is before to the
4 to the what? Tell me what to write.
1, 0 then.
Tell me what to write. What are we subtracting? What numbers are we subtracting?
We're subtracting 2 from 2.
You
So
subtracting what?
2 from 2,
Okay. Let's
exponent.
go back here. Okay. You subtract. I mean, you have different bases, right?
Yes.
Same power.
Yeah.
So 6 over 2, and then to the third power. Same power. Now let's go back here. So what's the answer?
Power. 4 to the second power.
4 to the second power. Yeah, that's what I wanted to go back so you could see from that example. So you divided 8 by 4 and you got 4. 8 divided by 4 is 2.
2. Yeah, it's an error. Sorry. 2.
Not 4, it's
Not
2.
4. Sorry. 2.
Okay. So that would be 2. Okay.
To the second
And
power.
2 to the second power. Right. Same. Question?
You know what?
60,
I think the
60,
16
what's 64 over 16?
64 by 16
Uh-huh.
is like dividing 8.
What is 64 over 16? That's the math. 64 divided by 16.
Would give you an 8.
Maureen, 64 divided by 16.
64 divided by 16.
Yes.
That
That's
would
the
be
math.
4.
It's what, Maureen?
4.
Maureen?
What is
64 divided by 16.
64 divided by 16?
Yeah, 64 divided by 16 is what? Not the
Let's
math,
see.
Maureen.
Okay, wait.
Not the math, no calculator. 64 divided by 16.
I'm doing it by the calculator. I got the calculator.
What is it? Not the math. What's 16 plus 16, Maureen?
32.
Okay, so what's 64 divided by 16? If two
Right.
16s make 32, how many 16s make 64?
How many 16 make 64?
If two 16s make 32, how many 16s make 64?
Or how many 32 makes 64?
Maureen,
Huh? Yeah.
two 16s make 32. How many 16s are there in 64?
4.
4, that's right. What's 2 to the second power equal to?
2 to the second power.
Yes, what number is that equal to?
I can't recall it.
No. What does 2 to the second mean, Maureen? Remember I said power means you multiply by the number of times that is the power. So what's 2 to the second equal to?
2 to the second is 4.
Right. It's 2 times 2. So you see it's correct, right?
Uh,
8 to the second is 64. 4 to the second is 16. 64 over
oh,
16 is 4. And 4 is 2 to the second, isn't it?
I see.
You see, I'm just showing you relationships here, how you can really check things. This is equal to 2 to the second. 4 is equal to 2 to the second. Equal 2 to the second. Got it? So you have a check on yourself. If you say, well, I wonder if that answer is right. Well, what's 8 to the second? 8 to the second is 64. 4 to the second is 16. 64 over 16 is 4. And 4 is 2 times itself 2 times. Got it?
Oh, yeah.
Okay.
I didn't know you were still doing that one. They thought you were doing the other one.
Oh, no, no,
Now,
no.
that way you can concentrate.
Oh, okay. All right. Now, that's where I have different bases and I have same power. What happens if I have different bases and different powers? What do I do?
Different bases, a different power.
This one right here, I have 16 and I have 4 different bases. I have a 6 and I have a 2.
Mm-hmm. So we will multiply 2 by 4.
Multiply, why would you multiply? Let's see, let me go here.
Divide.
Okay, now, okay, now,
Then the base
let me
and
just give you the rule. I gave you that one, but here's the rule. Different bases, different exponents. Bases and exponents are different. What do you have to do? Calculate each exponent. Like you said, Mercedes, with that other rule with the multiplication. So with the division, you evaluate each one and then divide. Okay? So that's so here's the rule, and then I'll go back to that one for you to do. So when the bases and the exponents are different, you calculate each exponent and then divide. And when I say each exponent, well, actually it's each exponent, it's not each exponent, it's each exponential expression. Calculate each exponential expression and then divide. So 6 to the second is 36. 3 to the third, 3 times 3 times 3 is 27. And then divide the results. Got it?
Okay,
Question
so that
on this
means
rule. Go ahead, Maureen.
So, Miss,
Maureen,
huh?
you had a question?
no, I was gonna say
No,
something.
Okay, go ahead, Melcy. Oh,
So you're
Maureen,
saying,
Maureen, what were you about to say?
No, let she go, let she go.
Okay, go ahead, Mercedes.
I was so you divide 27 to 36.
Right.
Okay.
You get it 1.33 or 1 and 1/3. 0.33 is about a third, right? 1/3.
Yeah.
You know the relationship between fractions and decimals, right? Should know them. I think I gave you a list before, a table of some common ones.
Yes.
So when the bases and the exponents are different, Mercedes, that's that rule you used on the multiplication before, where you said evaluate.
Yes.
Right?
I
So
understood
this,
part.
okay, so now you know when the bases and the exponents are both different, you evaluate both exponential expressions and then do the division. Now, let's go back to, okay, now I want you to do this one, 16 to the 6th and 4 to the 2nd, and tell me your answer. I give you a chance, you can do it on the calculator.
You're saying we should do the next one?
Yeah, 16 to the sixth over 4 to the second. Notice the base is are different. 16 is 4, and the powers are different, 6 and 2. I want you to tell me your answer. And I'll do it too, because I didn't do it. Okay.
Okay.
It's a really big number.
One, two, three, 4, 5, 6.
Maureen, did you sign your calculator?
I can get from my phone.
Because you said your TI 30 wasn't working, right?
So 16.
To the sixth power. Mercedes, you on your calculator, right?
Yes, miss.
What did you get for your 16 to the sixth power?
16,777,216.
Okay, let's see. Okay.
Okay. 2, 3, 4, 5, 6. Oh,
1-6. Say that answer again, Mercedes.
16,777,216.
That's correct. These technical things sometimes I'm trying to get it right on here. That is correct. That's what you have. I was trying to get it right on the screen. Okay. Right.
6.
Here we go. 1, 6, 7, 7, 7, 2, 1, 6. That's like 16,777,216. All right. And that's divided by, and what's 4 to the second, Mercedes?
16.
16. So when you divided that out, what did you get?
I got
I get 1048.
576.
Okay, that's good.
576.
Okay, 1, 0, 4,
That's it. 576.
5, 7, 6. Okay, so that's 1,048,576. So that's your answer. But the point is, when you have different bases and different powers, you have to do what? What's the rule? Mercedes, what's the rule?
Add the power, miss. I don't remember.
What's the rule? Dividing with different bases and different powers. What's the rule? You
You
said it.
multiply and divide.
No, I want to know the rule.
Oh,
When you're dividing and you have different powers and different bases. In other words, different exponents, different bases. What's the rule, Mercedes?
I think the rule is to add the exponent. I'm thinking because it slipped me right there. I didn't put add.
No, when we did the multiplication, you said the rule. And it's the same except it's division, not multiplication. So what do?
Subtract.
No, no. What's that key word, Mercedes? You used it back when we were doing multiplication.
Evaluate the.
Yes, evaluate
anyway,
each expression and then divide. So we evaluated 16 to the 6, and we got this big number, 16,777,216, and the 4 to the second, 4 times 4 is 16, and then we divided, and that's how we got our answer. So evaluate each exponential expression and then divide. That's it. That's the rule. Multiplication, you do the same thing, except you do what? You multiply instead of dividing.
So the
Got it?
exponent would be 3, miss.
The what?
The exponent for this answer.
No, this is the answer right here.
That's where we stop.
That's the answer.
Oh Lord, I forgot I'm doing it. Oh,
That's
yeah,
your
yeah.
answer.
That's the
One
answer.
million forty-eight five seventy-six.
Yeah, I forgot to we multiply the 4, 4, 4, 16,
Mhm. So
and
that's the answer.
and
16 to
16
this.
and 16
Yeah, this
69.
is
Yeah, yeah.
16 to the 6. Okay.
I just get carried away a while ago.
16 to the 6 divided by 4 to the second. And it's equal to this big number here, 1,048,576. Questions?
Sometimes, Miss, I get it because you put it on top of each other. If they were side and side, I catch on quicker. That's why I found out that I'm a little bit. That's why I made a mistake a while ago. But then, if they were
What
beside each other, then I would like.
you mean versus the slash versus the dash?
Yeah. Yes.
Yeah,
Yes.
but just remember with the slash, the one on the left is the numerator, the one on the right is the denominator. Like here,
Yes.
one on the left, that's the numerator, one on the
Yeah.
right. Because you will see them both ways now.
Okay.
Okay. Questions? So now you know how to divide with exponents. You subtract only when what? You have the same basis. Okay. But if you have different bases, different powers, then you've got to evaluate. Or if you had uh, different bases, same power, you do a division of the bases and then apply the power. All right, so we looked through the rules. There it is. Okay. All right.
Will you send those info to us, Miss?
Oh, you get this whole thing. I sent it to you last time. You'll get it. Did you get the one from last week?
I think so.
I sent the whole thing because I found when I tried to send it, it was blank, and then I had to like save it as a
Oh, and by the way, Miss, when I look online with the last week recording, it was not focusing. The view I couldn't see the letters plainly. The numbers, I mean.
Oh, they weren't big enough?
No, not big enough. It wasn't the focus. What do you call now? It's not clear enough to see like when I'm looking at this.
Okay, I'll have to look at it and see what's wrong. I'll take a look at it. Okay, different bases, different exponents. Need you to practice these. Do these for me. Tell me the answers.
You mean we have to do this now?
Yes,
I wasn't looking at it.
I'll do it too. And we see if we all get the same answer. And to the fourth over 3 to the sixth. Okay. Different bases. Now notice these all have different bases and different exponents, except the second one has the same. No, I'm sorry. They all have different bases, different exponents. So I changed them all. Okay, so let me do the first one. And then I need you to do them too. See what answers you get.
Okay.
Hello?
Yes.
Hello. That is 9/4, 3/6.
60. Which one are you looking at? 25 to the third over 125 to the 1 power.
Oh, that's
That's
125.
125 raised to the first power.
Really? Yes, oh, one leaf. Next one is 64. Put in negative. Oh, let's see. Let's go back there. What? Four.
Miss Barbara, are you still there?
Yes, I'm here.
Okay.
Students are working on problems.
Okay, I thought so.
Okay. Does anybody have an answer to the first one?
Yes, miss.
Power the same base.
My answer
Mercedes, what did you get for the first one?
9.
Okay. So you got 9 to the fourth. What answer did you get for 9 to the fourth, Mercedes?
6561.
Okay, 6, 5, 6, 1. Okay. And what did you get for 3 to the 6?
729.
7, 2, 9. And you divided that, you got 9. Maureen, did you get that one?
No, I didn't do it yet because you know, I mean, I got the
You
calculator.
don't
but-
have the calculator. Yeah, you need to get your calculator fixed. Because it's so much easier to put in the numbers and the powers and, right, Mercedes?
Yes, miss.
Okay. All right. Now, Mercedes, what'd you get for the second one?
125.
Okay, so you got 25 to the third is what?
15625.
15.
That's 15625.
Yeah, let me add it.
And this one's a smart little tricky one.
Okay, so you got, okay, let me write here. 1,
Uh,
5, 6, 2, 5.
5.
Okay, 6, 2, 5
Yeah.
over 125, because 125 to the
Yes.
1 is 125. What was
Did
your answer?
125.
Okay, and what was that equal
And
to?
125.
Right, okay, very good. That's the answer. What about
And
the
if
last one?
you-
Okay, Mercedes, you're on a roll. What about the next
Okay.
one?
The next one now. My answer is 0.000006.
0.6. That's 6.
I have 0.70 and a 6 at the end. Maybe I did it wrong, but that's what I tried.
No, what did you get? Now remember, when you have a negative, you can flip it and make it positive. So 64, let me just do this, to the minus 4 is equal to 1 over 64 to the fourth. All right. And 4 to the minus 2, let's put this here, equal 4 to the 2 over 1. Okay, so you can invert it and change the sign.
Me still get you have to start to break that part down a little bit because what I did is I put 64 into the calculator and then I go and I get in the -4 and that's why I get an answer.
Okay, well, let's just put, let me just clear this. Okay. But for negative exponents, they are the reciprocal of the positive. That's one of the exponent rules, and that you can apply here. Okay, but if you do it as a negative, now let's just take 64. Okay, 64, and then put -4. That's equal to 6 times 10 to the 7, right? Let's see, let me just insert and go to the next screen. Back here, using different bases and different exponents. Okay, let's just put in okay, 64. To the -4. That's 4 to the -2 divided by 4 to the -2. Now the first one comes up. Now I'm using scientific notation. It's 6 times 10 to the -7. Right? And the 4 to the -2, doing this on the calculator, okay. So we have 4 -2, enter.
Mm.
Okay, and this, I'll just put it on top. That's 6.25 times 10 to the -2.
That is for the 64, miss. Oh, no. Go ahead.
And to the -2. Now, when you divide that out, what do you get, Mercedes?
I don't catch on to this one, miss, when you do it. You want me to divide that one out?
6 divided by 6.25, and then you could use same base 10, right? -7 minus a -2. So let's do the 6 by the 6.25. just clear that. 6 divided by 6.25. Okay, that's equal to, will equal 0.96 times, and that would be 10 to the minus 7, right? Minus a minus 2. So we subtract, right?
Excuse me.
So that's 0.96. Okay, put the decimal point here. We're gonna move it later. Times 10. What's a minus 7 minus a minus 2? What's that equal to? That's a plus 2 and a minus 7, so that's a minus 5. And if I increase this to 9.6, then I have to decrease my exponent. So that would be 10 to the minus 6. That's your answer.
Well, Miss Emma lost to this one.
Okay. Well, I did it on the calculator. 64. 64 to the minus 4. On the calculator, I get 6 times 10 to the minus 7. 4 to the minus 2, I get 6.25 times 10 to the minus 2. So when I divided 6 by 6.25, I get 0.96. Then I'd subtract the exponent, minus 7 minus a minus 2. So it's a minus 7 plus 2, and that gives you a minus 5. But if I increase my base, I have to decrease my exponent. So for scientific notation, we don't leave it as 0.96. We move the decimal point between the 9 and the 6. And so since the base increased by 1, then the exponent has a decrease. And a minus 6 is smaller than a minus 5. Right? Remember from the number line? Questions?
So, okay, Miss. I don't kind of kick this one. She said I'm order my
Well,
relief.
this one
This,
was a little different. And actually, when I give you something like this, you wouldn't have to carry it out to this. Okay, let's go back to here. What I wanted you to recognize from a problem like this, let's go back here. Okay, is that when you have a negative exponent, it's reciprocal of the positive. So if you can recognize this, 64 to the minus 4 is 1 over 64 to the positive 4. And 4 to the minus 2 is 4 to the second. Actually, it's, yeah, 4 to the minus 2 is 4 to the plus 2 over 1. Actually, it's 1 over 4 to the second. Right here, not 4 to the second. 1 over 4 to the second, because you flip it and change the sign. And that's kind of basically what I wanted to get out of here. That's like a new rule. When you, well, not a new rule. It's one of the rules we hadn't gone through, but we'll get through it later, is that you recognize when you have a negative power, it's the reciprocal of the positive. Got it?
okay.
Negative power is reciprocal. Or if you can think of it as flipping it, you flip it and change the sign. So 64 to the minus 4 becomes 1 over 64 to the 4th. 4 to the minus 2 becomes 1 over 4 to the second. Not the 4 to the second of 1, be 1 over 4 to the second. Let me just take this out. Okay. Okay, so 4 to the minus 2, let me just write that here. 4 to the minus 2. Equal 1 over 4 to the positive 2. In other words, 1 over 16. So I wouldn't give you a problem like this to try to get the answer because, well, like Maureen, calculator is not working. You definitely would need this TI calculator, a similar one to do it, because with those you can put in negative exponents. But I want you to recognize that you can convert those negative exponents to positive ones by flipping them and changing the sign. Got it?
Okay.
Okay. But I went all the way through it because I wanted to bring in the scientific notation. Remember, we did that before, and I just wanted to get a uh, little taste of the scientific notation because we'll get back to that. All right.
Okay.
So the key here I want you to remember is that whenever you have different bases, different exponents, what's the key here? You've got to evaluate each exponent, each exponential expression before you do the division. Okay?
Okay.
So if you can get that out of this, then that's fine. That whenever you have different bases, different exponents, you have to evaluate each exponential expression before you do the division. Got it?
Yes, Miss, but the last one, I would like you to expound on that another time some more,
Yeah, I
please.
know. I just I didn't really plan to go that far on that, but okay. Right, I didn't plan to go that far on that. Now, okay, I'm not going to get into power to a power. I was going to get, well, I'll just introduce you to it, but we'll go over it in with some examples next time. But the other rule, now we've done the multiplication, we just did the division. The assignment that I give you will be on division only.
Okay.
And what do you do with the powers when you're doing division, Mercedes? What do you do with the powers?
You, when you're doing division,
Division, same base. What do you do with the
you
powers?
add them.
No, division, you subtract.
Oh yes, subtraction. What's wrong?
Multiply, you add. Division, you subtract. That's what you did on that first problem. You did the division, but we were doing multiplication.
Okay, so you do.
So if you're doing division, let's go back up here. I'll go back up here to the rule. See, dividing, subtract exponents. See the rule? Dividing, subtract
Dividing.
exponents. Numerator minus denominator power. Got it? That's what we
Okay.
just went through, dividing. And we did examples. We did it with the coefficients. Let's see, okay. Same base, subtract the exponents. Division goes with subtraction. Multiplication goes with addition. Just keep those pairs together, all right? Multiplication,
Can you please put back the first the rules?
back up here, okay.
You were showing us
Here
the
we go.
rules.
Multiplying, add the exponents. Dividing, subtract the exponents. That's what we went over last time, multiplication, and then we did a review of it, and we did it with coefficients, and then we did division today, and that's what your assignment will be on, practicing the division.
Okay.
Mercedes, you okay with that?
Yes, miss. I'll just keep my
So
review.
keep these pairs together now, dividing, subtract, multiplying, add. Now that holds when you have what? The same base. See,
Same base.
notice the A are
Yeah.
bases,
Yeah.
R are bases. So when the bases are the same, this holds. But now when
Yes,
you
okay.
start changing bases and powers, then you get into those other rules we went into, right? Let's see, let's go back. That was multiplication, okay. Same base, subtract, right?
Mhm.
Same base, there we go again. See, same base, 20, 20 is the base. Just
Mhm.
subtract the powers, right? Same base with coefficients, what do? Divide the coefficients, subtract the powers, just like we did before. Got it?
Mhm.
Okay. Same thing, same base with coefficients. P are the base, 16 and 2 are the coefficients. Divide the coefficients, subtract the powers, right? Now, but when you get to different bases, what do? A and B are the bases. They are different. You divide the bases and then you just carry the power.
Mhm.
Different bases, same power. Divide the bases and carry the power. Got it?
Mhm.
Okay, so all of this I will be sending to you. And there was a different base. And now when we have different bases and different exponents, what do? We have to evaluate each expression
Expression
and
with
then do the
same
division.
divisions.
That's it. Got it, Mercedes?
Okay, miss. I just keep
Okay.
on study the
Yeah, you
rules.
can go back through these and I just wanted to just go over the power to just introduce you to a power to a power. Now, a power to a power means you have a power inside the parentheses and a power outside.
Outside.
That's all. A power to a power. A power inside, a power outside. And what do? What's the rule?
Multiply.
Multiply the exponents. So you have a power inside, power outside. Just multiply the power inside by the power outside.
Side.
So a to the m raised to the n is a to the m times n.
Okay.
Put numbers on it. X to the y to the third raised to the fourth power is y to the 3 times 4, or y to the 12. 4 to the second raised to the fifth power is 4 to the second times 5, or 5 times 2 is 10.
Mhm.
And then x to the second raised to the 0 power, 0 times 2 is 0. And any number of variable to the 0 power is what?
One.
1. Okay, so we will be working on power to a power next time. We'll look at these rules
Okay.
and do some examples. Any questions on anything we've gone over?
No, thank you, miss. I was expecting those rules. These new rules show us today.
Yeah.
So
Well,
I can
Mercedes,
review them.
I expect you to get them all correct this time.
Yeah, miss. I just
Remember, it's optional for you to turn it in. So it's the one I give you on Thursday, that's required. But the one I give you on Monday is optional. But just so you understand everything, it's good to practice them. That's why I call them practice assignments. Okay. And Maureen, I know Maureen loves to.
miss just a remind it says that what you gave us today should come in before Monday too.
You mean the
That
assignment?
is optional.
No, the assignment is not required. I mean,
But if you
you
want to send
should do
it,
it, but you don't have to send it to me, but it's optional.
Okay.
if
Not
you want to
only,
send it, you can send it. If you don't want, you don't have to.
that's it. Maureen told you very clearly what I
So
had
what
said.
about Thursday one? The same
Thursday is
thing?
required.
Oh,
Thursday
okay.
is required.
Monday is optional.
Okay, it's up to me. Okay.
It's up to you. If you want to do it and turn it
Or if
in,
it
it's all right. If you want to do it, just have me check it. It's okay. If you want to just do it. Either way, I'm going over it the next session. Okay.
Okay.
All
Thank
right.
you.
Yep.
Yeah, because since you come twice, I didn't want you to be under pressure of of a Monday, getting it ready for Thursday, okay? So you do
Uh,
what you
the,
can on it, and you have questions on it, we go over it
the
during the
next
Thursday,
class
during
today
the,
start 4:30, miss.
mhm.
You say next class start today 4:30.
The college prep math starts at 4:30.
I'm not sure I'm gonna get on.
Yeah, we'll
But
be doing inequalities in that class today, so one of your favorite subjects, Maureen, right?
yeah,
Maureen laughed. Maureen, isn't that one of your favorite subjects?
And, probably not.
my only problem to them is I want to sleep so much. I haven't slept much since I came home this morning.